matches with B. Number 12 matches with F. Number 14 matches with C. Make sure you're grading homework. Remember, if you don't grade, you lose points. Oh, that's a bummer. Number 36 was your first needing to focus? No. Needing to identify. Needing to identify the key pieces and then sketch, right? But this one, well, it shouldn't have been too bad. It was a little hard. Why was this one a little hard? What did you have to do first? Yeah, was this standard form? Not yet. So you had to move the non-squared to the other side. What's this, Jazz? What's going on there? Some of you guys got confused as soon as it wasn't in standard form, even though I warned you about it yesterday. So, right away, remember, even when we were doing this in class, I said, what's the form you want it to look like? And in this one, guys, what's the form you want it to look like? Right away saying it's y minus k squared. The squared is by the y, just like we saw yesterday. Whoever is squared belongs here on the left. Now, what does that mean about the right? Yeah, that's the form, true, from that yellow box? Okay, so when we rearrange, we get y minus, that's a minus, 1 squared equals negative, because we have to subtract it, x plus 5. Because we would subtract, now you could have thought minus x minus 5, or you could just minus the whole x plus 5. But, I mean, I see my k, I see my h, but what don't I see? So what do I have to do? Remember what we saw yesterday? Can't we make a little baby equation saying u must, remember if there's nothing there, it's an understood 1? So what would p end up equaling without even making it look all crazy like the answer key did? Because the answer key is like, I'm a genius. I'm going to write 4 times negative 1/4. Ha-ha. Whatever. What could you have done? Right? Now, for my visual people, if you're getting an understanding, look at who's squared. Yeah? Look at who's squared. Is this an up-down parabola or is this a right-left parabola? Yeah. Y equals x squared. Oh, remember, x squared is up-down. X squared. Yeah? So y squared must be the, yeah. Now, who's p, though? Negative. So negative, you're not facing the right direction. See what I did there? So where are you facing? Left. Yeah? Okay, so right away I know that there's something like, awkward, sorry, I didn't mean it to be a highlighter. That's okay. So what are you supposed to identify? Who's your vertex? Okay, it's the h, right? And the h is with the x. Good, so negative 5, because it's x minus h, negative 5. And then positive 1, sorry, y minus 1. It's y minus 1. Who's my focus? Did anybody go for a sketch right about now, being like, it just got hard as soon as you saw focus? Now, some of you were like, I have my nice picture of everything I need to memorize. Okay, cool. Yeah, you could plug in and you would get it. But for everyone else who's like, I don't want to memorize, okay, you have to think about what's going on. So if you have the point 1, 2, 3, 4, 5, positive 1, and if it needs to be a left-facing parabola, where's the focus? You're focusing to the left. Oh, wait a minute. How much to the left? 1/4 to the left. So my visual people, if this is negative 5, 1, I'm going to rewrite this as, I know it's awkward, but can't we rewrite this as negative 20/4, 1? Why am I saying that? Because you're at negative 5, negative 24, so you need to go 1 more, which would be negative 21/4. That's where the focus is. It's just a little bit past. That looks like a half. Sorry, it's supposed to be a 4th, but my dot wasn't quite in line. Anyway, there's negative 5, there's negative 6, and technically this guy is supposed to be negative 5 and a 4th, or negative 21/4. That's my focus. Where's my directrix? What kind of line is my directrix if I'm facing this way? My focus will be here, right? My vertex is here, and my directrix is? What kind of line? Are you gliding, y, or are you dying, x? x equals. And what x, well, wait a minute. Isn't it 1/4 the other direction? So instead of negative 21/4, negative 20/4, it's negative 19/4. Why? Because that distance tells me everything. That negative says, oh, you're headed left. Your focus is to the left, which means your directrix is the opposite direction. Oh my goodness, I think we're done. Did they ask you for axis of symmetry? Oh, well, forget that. Check, check, check. I'll go back. You can see the answer key. Why did I spend so much time? Because this one really made you work, didn't it? It wasn't in standard form. You had to rewrite it to get it into standard form. And once you had it in standard form, did you know what to do with p and it was a nasty fraction? But for my guys that are like, no, I'm going to memorize that page. I'm going to take that picture and memorize it. Can you plug into formulas and you get to the same place? Yeah. Yeah. H plus P. Dun, 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 dun. Why is it so close? Because, guys, they're going by 2's, and this is only how far away? 1/4. Oh, and it was the only other even. Okay, does that mean that's as hard as homework got? No. Can someone tell me, from that same section as that problem we were just doing, oh, wow, I just went into inclination. Sorry. Is there any problem around number 36 that got even harder than that one? There should have been. How come? Did anybody need to use completing the square? Ooh, can we go see how you did on completing the square? Is that okay? Okay, that's section 10.2. And what did you guys figure out what number needs complete the square? 41? Oh, yeah, it does. In number 41, my question to you is, what standard form are you trying to make it look like? Who's squared? Yeah, do you guys agree with Tony? I hear him saying it back there. I think Gavin's saying it too. Who's squared? No, it wasn't. Was it Aiden? Was it Wyatt? There's too many guys like right in a row. Switching up. I only have so many girls to spread out, and I can't let them like not have any girls around them. That'd be sad. Usually Kim's closer to Vico. Yeah. Wow. Hey guys. Do you see a pattern as to what I'm doing every single time and every single problem, whatever it is they give me, clues or graph or equation? What am I doing every single time? Who's the standard? Yeah? Ooh, is there a life lesson to that? That we need to have like standards, we need to have truth that we stand on, and we keep on going back to that despite good life lessons. Okay, but no time. Yep, these guys definitely don't belong, right? So we can say, okay, fine, I don't know exactly what I'm doing. Ooh, did you leave a space when you moved it? Should have left a space because it's the no. I mean, it's a quadratic. The y is a quadratic, but I don't have a perfect square. So I make a perfect square. What did you guys add? Add one side, I add on the other. I'm not on the same side, so I don't need to make it 0 in the sense of add and subtract. I'm on two different sides. And what do you want this to factor to be? Y plus, you have to take half of that. Two ways of doing it. One way is to figure out who you want it to be. I want it to be y plus 3 squared and say, who am I missing? Oh, a 9. That's one way. Cut that guy in half, so it'd be y squared plus 3y plus 3y plus. I have my first, I have my outer, I have my inner, I need my last. 3 squared is 9. But if I do that there, what do I have over here? Well, that doesn't look right. Oh, that's okay. What can we do? Factor out a negative 8, and I get x plus 2. We have options. You could be like a smarty pants, like the book, and be like, oh, that's going to be 4 times negative 2. Look, it's my p. Or what else could you have done instead? Could have made the equation and said, well, I know I need it to be. And what do I have? So whether you make a little baby equation off to the side or whether you rewrite it, either way it's going to work. If 4p has to make -8, then p is -2. Either way, you get it. And then you can go ahead and identify everything like we just did. Isn't this also going to be like a left? I only gave you guys left ones that were hard? Oh, sorry. It would have been nicer if I given you like an up one or a down one or a right one. But I think you had some up, down, right, and other problems, right? Look at your pictures. Did you have some other ones besides just facing left? Okay. Okay. So I made you practice other ones too. Pico. Oh. Because complete the square, remember? Oh, sorry. When I'm trying to get... You mean this 9, right, Pico? Okay. I needed to make it a perfect square. And so the formula way to do it is to take the middle term and to cut the middle term in half and then square it. And what I'm doing is I'm thinking of if 6 needs to come from a perfect square, it has to be cut perfectly in half, 3y, 3y. If it was any other way, 2 and 4, 1 and 5, it won't be a perfect square. But 3 and 3, good. So then I say, okay, 6 over 2, 3 squared, 9. Yeah. Any other questions on complete the square? It's always tricky when we see it, but one of these days we'll have it mastered. Maybe by Calc BC. No, it's funny, the calculus kids are like, oh, I think I actually have algebra mastered now. I'm like, about time. It's about time. Some of them are like, nope, still can't FOIL. I'm like, it's a choice. It's a choice. Not for everyone. It's not for everyone as far as not everyone can just choose to master algebra. But those of you guys that have gotten to this level of math, it's a choice as to how much you dig in and make sure your brain fully studies, learns, comprehends, masters a topic. Robbie. Whoa. Yeah, right. Any other homework questions? Going once? Going twice? Odds or evens? Oh, we do have questions. All right, Vika, what do we got? 57. Gavin, what else? Okay. So let's start with number 43, just because it's sooner, and then we'll go to 57. Oh, don't worry, Vico. This is exactly what we're going to learn right now is tangent line. We didn't do it yesterday, so hold on there with 57. And then 43. Oh, there's 43. I couldn't find him. Find the vertex, focus, and directrix. Use a graphing utility to graph. Well, actually, Gavin, this one on 43, I think you're only supposed to use the grapher at the end.
Yeah, I did the vertex.
Okay, it was just the graphing part? Yeah. Yeah. Well, if you're finding or you said you did find all this stuff, right? Okay, cool. If you were to do that, then that means that you probably did something to the effect of eventually getting to x plus 2 quantities squared equals, and then you have a negative, and you had to add a 4 and add a 4, and 4 and 2 is 6, and you pulled out the 6, and then you got the 1. And that was plus 2 and a minus 1. Is that right? Sorry, I did the mental math really fast with completing a square and moving, and it was a little overwhelming. We're good?
Yeah.
Okay, cool. But if we have this is great for finding, but it's awful for graphing on a calculator. Yeah. I think they're trying to show you that if you find all of these, it's actually easier just to go graph it by hand than to go to a calculator. That's what they're trying to show you. To be honest, to get to a calculator, this doesn't help you at all. You should have just gotten y by itself. Because in a calculator, we need y1 equals. So actually, even though this was crucial for all of those, and this is so helpful for graphing by hand, to graph with a calculator and make sure you're right with all of your clues, I would have just come back to the very beginning and said, oh, okay, well, just move your x squared, move your 4x, move your... Oh, yeah, this is how we used to do it. Does that make sense? So then you would have just thrown this into your y1, and then you would have gotten your graph, and you would have made sure that it was okay. But your graph should have, or you should have in your graph, seen like a little bit of a horizontal translation, left 2 and an up 1, and then you have a boop, boop. And then with the negative, hey, here's a downwards facing one, because isn't x squared up, down? Negative, oh, I'm focusing in the negative direction, so I'm going down. And then your, oh, this is kind of a nasty one. Maybe that's why they were trying to be nice. It would be 4 times negative 3 halves, right? Yeah? Because then 1 and 2 and 6? Yeah. Then you would have had to go down 1 and a half to get to your focus. You would have had to go back 1 and a half to get to your, your directrix. And then you would have had your, there he is. But you should have probably found intercepts to make it all nice and pretty and perfect if you were doing this by hand. But anyway, Gavin, what you should see, remember, you're not going to see your directrix, you're not going to see your focus. All you're going to see is your parabolic reflector. But sorry, this isn't a word problem. Your parabola. Yeah.
Should we use the Connex app to kind of graph it?
Yeah, you could. You could, since you have it in your form. But in this one, like, to be honest, they were having you check. So, Johan, unless you already went to the back of the book and you were already sure, I would have, just because I know myself and I make mistakes sometimes, I probably would have gone back here anyway, just so that way I'm like, I think it's this. Is it really, to double check my work? Because if you put this in your Connex app, you could have made a mistake from here to here. Does that make sense? So just a warning. But yeah, that's a good point. That's a good point. And then, Tony, you got your calculator back, right? Cool. And I think, oh, there was a lunchbox or something that was yours. Okay, good. Just making sure you got that too. All right, let's leave this and let's go back to Vico. I'm keeping the book up for number 57. I'm going to take a picture of it. But first, let's go talk about how to do it in general. Does that sound good? Vico brought up a good question. We don't know how to do this yet. So in our notes, you took down, oh, nope, back. There we go. This page just a second ago. All right, here's an application of the standard form of a parabola. Here's an application of the standard form of a parabola, or dealing with foci and directrices. Well, wait. Do you see a directrix in this picture at all? No. So for a tangent line, we don't need to think directrix. For a tangent line, we just need to focus. Ooh, it's a life lesson in that one too. Anyway, coming back. Another application, finding a tangent line to a parabola at a point. There is a reflective property of a parabola, and the reflective property of a parabola says, the line passing through P, who's P? Just a point. What point? Any point. Any point? Any point on the parabola. Any point whatsoever. P is any point on a parabola. A line passing through the P and the focus. Do you guys see that line? Can we code this a little bit? The line passing through the point P and the focus. That would be this little blue one, right? P and the focus. Okay, so that's what that part's talking about. And then the axis of the parabola. Oh, the axis of symmetry. Isn't that this guy? Guess what's true between these two? Can you guys see that there is a line that connects them and that these angles are congruent? And when we have an isosceles triangle where two angles are congruent, what does that mean about their opposite sides from geometry? If the angles are congruent, then the sides are congruent. So check it. Can't I say, do you remember from geometry how to show congruence? Congruence that way. Okay, so if we connect any point P, any point on a parabola, with the focus, the distance is going to be the exact same as the distance from the focus to, wait a minute, how do you know when to stop? Because the point P distance formula, I can find no big deal, right? x1, y1, x2, y2, I can use the distance formula. Ooh, where's this going? Yeah, whatever this distance is, if you go that focus along the axis through the parabola, you are going to hit what we call the tangent line. Now, this is probably the first line that was not to a circle, because in geometry, we only saw tangent lines to circles. Tangent lines and secant lines, to be honest. This is the first time you've seen a tangent line to something other than a circle. And for right now, to be honest, the only thing that you can do tangent lines to are quadratics. Now, if you talk to a Calc AB or a Calc BC kid, they can do tangent lines to any curve. you guys? Well, actually would have been impossible for you to do anything besides a line to a circle up until this section and up until this point. So what is the one that we can find? Well, we can find this guy using the distance formula. Between who? Between the P and the focus. So we're going to use P and we're going to use the focus to get D. And once we get D, that's going to be our step number 1, distance formula with P and the focus. Step number 2 is going to be to go from the focus down along the axis, whatever D is. That's going to be step 2. We're going to find a new point. This is going to be our x3, y3. Because we will have already been given a point P. That can be our x1, y1. We can find our focus. We've spent a whole homework doing that. That's going to be our x2, y2. We're going to use those two to get the distance. Then we're going to measure that distance down to get a new point. And guess what we can do once we have a new point along a tangent? What can we do whenever we have 2 points? What can we find? Oh, we could find that distance if it was important. But they don't want the distance. They're going to say then we can find the tangent line. Because then we can go ahead and find y equals mx plus b. Probably using standard form. Not standard form, point slope form. Probably using point slope form. But we're going to go ahead and after we find the distance between P and the focus, use the distance to get a new point that's on the tangent line. Then we can use the original P and the new point to make the line itself. Our objective, our goal, sadly that you cannot choose whether or not to accept it, because it's accepted for you, is to find the tangent line. Goal was to find the tangent line. So once we get to step number 3, booyah, we got it. So let's go ahead and do an example. Step number 1, distance between P and focus. Step number 2, measure the distance away from the focus to get your second point for your tangent line. Step number 3, make the line. So here we go. Step number 1, distance between the point P and the focus. I don't have a point P. Yeah, you do. Where is he? Right here. There's my point P. I don't have a focus. Then get it. That's what the whole homework was. Get your focus. Focus, focus. So we have y equals x squared, right? If y equals x squared is my parabola. Isn't 0, 0 my vertex? Where's my focus? What am I doing? What do I do every time? So who's P? I don't know. Okay, so rewrite them. Okay, well, I have x minus 0 squared equals y minus 0, right? That goes there and that goes there. And who's here? I've already seen 1/4. My question is, would the rest of you guys see 1/4? If 4p equals 1, doesn't p have to equal 1/4? Did you have one of these in homework with a 1/4? Oh. Yeah, there was a negative. Good, 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 good. So if 4p equals 1, then p equals 1/4. If p equals 1/4, what can I do? Find my focus, because my focus then will be, if that's 1, 0. Why? The parabola says focus, right? Wherever the parabola is, wherever the concavity. Focus, focus, focus. Because I care. Come here, bud. Jason. It's okay. It's okay. It'll just help you. It'll help you. So, focus, right? 0, 1/4. Because p equals 1/4. Why did I find the focus again? Yeah, go back to your steps for the tangent line. I'm supposed to find D between here and here. Don't I know 1, 1? Can't I graph 1, 1? Oh, okay. So here's my point P, and here's my focus F. And what was my job? What was my objective? Step number 1, find the distance. Okay. How do we find the distance between points? There's a formula. Yeah. Oh, come on, guys. You don't remember it? You don't need to remember it. All you need to do is know the Pythagorean theorem. What? No. Yeah. Remember? This was back from, oh my goodness. Can you go to section 1.1? Awkward. Section 1.1, literally, in the notes. Section 1.1. We talked about midpoint, and we talked about distance. And how do you find distance? You do one x minus another x. What's 1 minus 0? What's that distance? 1. What's the change in y's if you go from 1/4 to 1? 3/4. I see what you're doing. You're going this way, right? 0 minus and 1/4 minus. I was just going the other way. 1 minus and 1 minus. And what's the distance formula? It's Pythagorean theorem, guys. It's really just a right triangle. So D equals, okay, yeah, you could have memorized x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Or you can just say, oh, it's a squared plus b squared square rooted, where a is delta x and b is delta y. So you're going to have 1 squared plus 3/4 squared. Is that a little bit awkward? Yeah. But that's okay. We're in pre-cal. Shouldn't we be able to multiply fractions to get 9/16? Shouldn't we be able to get common denominators to get 16/16 plus 9/16? Shouldn't we be able to add fractions with common denominators to get 25/16? And shouldn't we be able to square root and to get 4/3? Ooh, 5/4. Just kidding. Technically plus or minus, but what is D? I don't care about direction, Robbie. I just care about how much. So how much? Think absolute value. Yeah, good. So what did I just find my D to be? 5/4. Step number 1, done. Distance between point and focus. Step number 2, can you look? Use the D to do what? Go away from the focus. It's time to go away from the focus. How much? 5/4. So where do I end up, cool kids? 0, -1. For those of you that are like, what? Remember, we're going down, so the x doesn't change. It's still 0, but the y changes from positive 1/4 down 5/4. Well, what's 1/4 minus 5/4? -4/4, -1. What did I just find? Out of all the lines that could have, out of all the infinitely many lines that could have gone through point P, I just found the one point that establishes the perfect tangent line. Out of the infinitely many different lines, finding the distance and going along the axis from the focus, the distance, I found the one point on the y-axis that the one line that I want goes through. So step number 1, find the distance. You guys see it? Step number 2, go the distance. That's, never mind. No High School Musical. To get 5/4. And then step number 3, find your line. Well, guys, how do I find any line in between 2 points? Easy cheesy, right? Because all I need is my slope and point slope. So can't I go ahead and just say y minus equals m times x minus? Give me a point. 1, 1? Cool. Give me an m. Huh? Oh, okay. Rise over run. Aren't I going to go up 1, 2, and go over 1? Could you do y2 minus y1? 1 minus -1 is 2 all over x2 minus x1. 1 minus 0 is 1. 2 over 1 is 2. Yeah, but what do you end up with at the end of the day? Y equals 2x minus 2 plus 1 is minus. Oh, yeah, that's the intercept, and that's the slope. Okay. Dun 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 dun. Tangent line is right there. Is that cool? But what did we have to do? Find the focus first if they don't give it to us, right? So technically, is there a step like -1 or 0 or whatever? Step 0, there you go. Find the focus. Okay, step 1, distance between the point and the focus. Step 2, move the distance. Step 3, make the line. Done. Vico, I'm going to have you go ahead and try that tonight, and then I'll see tomorrow how the tangent line problem or problems go. Okay, with that, section 10.3, what other conics are there? What other conics are there? If I had more time, I would illustrate to you an ellipse. I'll do it tomorrow because we don't have time today. But an ellipse, well, the idea starts off with x minus h squared plus y minus k squared equals r squared. But that's not an ellipse. Who is that? It's a circle. So how on earth does that help me for an ellipse? Well, an ellipse is a circle that's been stretched horizontally, shrunk horizontally, which is the same thing as being shrunk vertically or stretched vertically. I need a rubber band. Excuse me, pardon me, excuse me. I need a rubber band. Ooh, I have a nice big one too. I need a rubber band. Now the visualize, the visualize thing, guys, it's totally okay. Just leave that blank. You don't even need to really like skip a line. Just write visualize. We'll do it tomorrow when we have more time. If I were to make this a circle, a perfect circle, is that a perfect circle? No. But is it close? Okay, it's close. If I was to stretch it horizontally, do you guys see how stretching it horizontally is the same thing as shrinking it vertically? If I pull horizontally, isn't it the same thing as if I was to push vertically? See it? So a shrink vertically is the same thing as a stretch horizontally. And a shrink horizontally is the same thing as a stretch vertically. Does that make sense? So I can either say it's horizontally shrinking, vertically stretching, or it's horizontally stretching, vertically shrinking. It's going to be the same thing. But how do I get shrinks in here or stretches in here that affect one part of it one way and affect the other part the other way? That's where an ellipse comes in. Visualize. I'm just going to go ahead and delete that page for right now, because I can show you that tomorrow. Standard form. Do you remember the yellow box in section 10.2? Actually, both of them were pretty important. The yellow boxes kind of gave us the standard forms that, man, I was using nonstop in every single type of problem. There are standard forms for ellipses, too. So I'm going to go ahead and zoom in on that yellow box, because that is the key. If you need to skip a couple lines, totally fine. We'll come back to visualizing tomorrow. But what's going on for these equations for an ellipse? That's what's coming up here. What's going on with the equations for an ellipse? Okay. Do you see anywhere in there the equation for a circle? It's distorted, but it's there. Do you see it? X minus h squared plus y minus k squared equals, there's no r squared. That's okay. It was divided over. But wait, there are two different values because there are two different radii. I have to go quote unquote because a radius, isn't it a set constant that's all the way around? This isn't all the way around, but check it. Isn't x a horizontal measure? So A is going to be the horizontal radius, and B is going to be the vertical radius. Now you'll see tomorrow when I show you the visualization for an ellipse how this can all come out of like one rotation. It's not like a compass where there's one measurement and it's all the way around, but you'll see it tomorrow. How they come out of a revolution. But if you notice, the radius, quote unquote, is always changing. A is the biggest it can be, and B is the smallest it will be. If you're thinking about the radius, it increases to there, and then it decreases to there, and then it increases to there, and then it decreases to there. Kind of like a waxing and waning. Ooh, waxing and waning. When do we talk about waxing and waning? Is it phases of the moon? So in a way, our radius increasing and then increasing. A is the largest, B is the smallest. Well, or, hold on, can it go the other direction as well? So hold on, who is A and who is B? In this one, A is the horizontal, B is the vertical, but in this one, who's going to be the horizontal this time? B is going to be the horizontal, and A is going to be the vertical. Okay, so wait, maybe A isn't always horizontal. Who is A then? A is the biggest. Good, do you see it? So for both of these, A isn't always horizontal. Sometimes A is vertical. A is what we call the major radius. And B is what we call the minor radius. The major is the biggest the radius can go. The minor is the smallest the radius can go. But do you guys see how I measured up who was horizontal, who was vertical? You're looking to see what's it under. Is it under the x minus h squared or under the y minus k squared? There is something kind of important about these formulas that you guys wouldn't realize is super important until next section. But this plus is crucial. The same way we need x minus h squared plus y minus k squared for a circle, we need it for an ellipse as well. If it was a minus, we'd be in some big trouble. Well, or we'd be in section 10.4. Anyway, do you guys also see there's this thing called a major axis over here to the side? But does it make sense who the major axis is? The major axis is just the guy with the longer side, right? The major axis is just the guy with the longer side, or the longest measurement. We could talk about like major and minor diameters, but it's okay. So what we do in parabolas once we had a standard form? We practiced, right? What are they going to give us? Clues. What are they going to give us? Equations. What are they going to give us? Nice standard form equations or non-standard form equations that we have to do complete the square to? Maybe. What are they going to give us? Graphs? Sure. It's going to be like section 10.2, but not parabolas anymore. What do we have now? Ellipses. Can we at least do one example before we leave? Is that okay? Okay, stand up, give a high five to somebody, and let's do an example. Oh, that's no fun. Keep going. Stand up. High five somebody. Quick, 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 quick. We only have so much time. Just jump it out just a little bit, because I know you guys are tired of sitting. Sit, 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 sit. Here we go. As you sit down, there's one formula that we did not write down that was not in the standard form. Who on earth is C? What does this look like? Guess what ellipses? Oh! Guess what ellipses have too? Foci. Who are foci? Parabolas, we only had a focus. Oh my goodness. Radius, radii, focus, foci. It's a plural. Guys, if you were to break down an ellipse to be two parabolas, which it's not, it's really, really, really not. But if you were to kind of think about that, we could technically call this, on the major axis, we could call this a vertex. And we could call this a vertex. Actually, some people do. Where would your foci be? Somewhere here. And somewhere here. Oh my goodness, there are foci for ellipses also? Yeah. But do you see a point P anywhere in this? Nope. I don't see a P. But do you see A's and B's? So guess what? C is how far away from the center the focus is. Remember how HK isn't a vertex for an ellipse? It's the center. So if this is my vertex, and if this is my vertex, where's my focus? Inside. And how far is that focus going to be? C. How far is that focus going to be? C. Oops, sorry. Zoop. Zoop. Okay, do you guys get your c squared equals a squared minus b squared? Why does it need to be a squared minus b squared? Isn't a the farthest out you go from the center for an ellipse? Doesn't c need to be something inside that, so there needs to be subtraction? Ooh, it's like Pythagorean theorem, but not. Find the standard form of the equation with the ellipse. Hey, who's stronger? Who's bigger? Who's major? Who goes first? X or Y? From the picture, who's major? X, horizontal, or Y? X. So we're going to go ahead and, just like I did all the ones before, So why does he get the A? Because he's the major one. What do I plug in? Can you guys tell what the center is just by looking at the graph? Yeah, the center is totally 0, 0. Why? Because it's the midpoint of each of my major and minor axes. Okay, sweet. So x minus 0. Why am I going to put 2 squared? A is 2. What am I going to put underneath y minus 0 squared? 3 halves squared. Box it, you're done. No, you're not. That's gross. Shouldn't you do maybe an x squared over 4? And shouldn't you maybe do a 9/4, pop it up, 4y squared over 9? No. Maybe. Ah! Couldn't you get a common denominator multiplying everything by 36? Are there different standard forms? Yeah. Bye, guys. I'll see you later. He's an ellipse. He's an ellipse. He's an ellipse. You're going to have to look in the back of your book to see which one you should keep. Later. Later, Gators.